Hello students, welcome back to EduBig Global Solution, and again in our mathematics class we're going to be looking at differentiation rule. Okay, we have our interactive content here that will serve as a guide for this class. Okay, now when you're talking about differentiation, we've made mentions of it like in the earlier class that for us to differentiate, our derivatives and the gradient function must be known, and we have a function y and independent variable x, and that's what we use for our differentiation. So the process of finding the gradient function is known as what? Differentiation. Differentiating a function produces the derivative or gradient function. And what is that type of function that we basically differentiate? We differentiate a function y with respect to x, which is independent variable. Okay, now we have some rules there that are going to be serving as a guide even for us to differentiate any given function. Okay, the first rule here says that the derivative of a constant is 0. So if the function f of x equals to constant, which is c, the y dx equals to 0. So whenever we are differentiating any given constant, our answer is going to be what? Our answer is going to be 0. So we have a function here that we have to differentiate, and let's see what we have if you have to differentiate. Remember, our differentiation formula is y over the x equals to n s n minus 1. So we have a function here which is f of x equals 3. So we have to differentiate this one with respect to x. So let's assume that f of x equals to, that is y equals to. So if we are differentiating with respect to y, that is y, the y dx equals to, if you look at it, the coefficient here is even 3. We don't have any power of 0. So we have it to be what? 0 multiplied by 3. Okay. X, we don't have, we don't have x raised power what? X raised power 0 minus 1, because n, so n is 0 and we have minus 1. Now n raised power 0 is what? N raised power 0 will give us 1, but imagine this is a negative value, so we have an expression in such a way that we have 0 multiplied by 3. 0 multiplied by 3 will give us 0, and 0 multiplied by the coefficient of x also will give us 0. So that gives us a guideline for this rule, that any coefficient that is a constant value, by the time we are differentiating it, answer is going to be what? To be 0. So what's the formula for a differential equation here? It is a(x) raised power n minus 1. By the time we differentiate it, 0 times 3 multiplied by x raised power 0 minus 1, every of our answer will give us 0. And that implies that for a gradient of a function that is a constant, it doesn't have any specific gradients because our answer is 0. Now let's look at the next rule that we have here. If a function equals x, the function of f is equals c, the y dx equals a. So if you have a specific function and variable x is raised to power y, raised to power 1, okay, so by the time we are differentiating it, we are going to have a constant value as an answer. So that's what this differentiation is telling us. Let's look at this example here. Differentiate the function f of x equals to 2x with respect to x. So we are using the formula the y dx equals to a x n raised power minus n minus 1. Now let's express this as a function of y. So y equals to what? 2x. If you look at it, n here is going to be 1 and a is what? A is 2. So we have it to be 2 multiplied by 1 x 1 minus 1. So that is 2 multiplied by 1 is 2, right? So we have x 1 minus 1 will give us 0. And under indices, n raised to power 0 is 1. So 2 times 1 will give us 2. So for this one, if we have to differentiate this, the gradient, the graph of that function is going to be a straight line. Now, why are we saying that it's a straight line? Let's look at it. We have told us that our y here, by the time we differentiate it, our y is what? Is going to be 2. So if we have y equals to 2 here, then our x can range from 0 to whatever we draw a straight line graph. So now let's look at the arrangement for this solution and let's get it done. Okay, what's the formula for differentiation? That is a x raised power n minus 1. 1 times 2 is 2, right? X raised to power what? 0. So if you have that, is going to give us what? 2. Because n raised to the power 0 is what? N raised to the power 0 is 1. Okay, and that gives us the solution to that problem. Now let's look at the next rule that we have here. The derivative of a function with several terms can be found by differentiating each of the term individually. So if we have a derivative of a function, a long functions with a several terms in it, all what we need to do is what? We differentiate each term individually using our differentiation formula. So let's look at the work example that we have here. Differentiate f of s equals to 1 over 3 x raised to the power 3 minus 2x plus 4. So let's differentiate using our formula. The y over the x equals to a n x n minus 1. So for this first one, I said that we have a term. This is another term. We have another term. 1 over 3 x raised to the power 3 is a term. Minus 2x is a term. 4 is also a term. So we are going to be differentiating them individually. So we have y equals to 1 over 3 x raised to the power 3 minus 2x plus 4. Now let's differentiate this first one. A here is 1 over 3, right? N is what? N is 3. So we have the y, the x equals to what? 1 over 3, okay, multiplied by 3, x 3 minus 1. That's the first one. Now the second term that we have here, minus 2, a is 2, n here is what? S raised to the power 1. So it's going to be multiplied by 1, s 1 minus 1. Now the last one here, which is what? We have 4. If you look at this, it doesn't have a coefficient of 4 doesn't have any variable behind it. So we don't have x value. So our x value is going to be written as 0. So we have 4 times 0, x 0 minus 1. 4 times 0 will give us 0. So all of this is 0. Now let's look at this. 3 can cancel 3 here, right? So we have 1 multiplied by x. 3 minus 1, that is 2. So we have x raised to the power 2, okay, minus 2 times 1 will give us what? 2, okay? X minus x, that is x raised to the power 0. So we have x squared minus 2 raised to the power, x raised to the power 0 is what? That is 1. So we have 2s, we have x squared minus 2. And that's the solution to that problem. So let's look at the activity here and let's rearrange. The formula for calculating differentiation is what? Anx n raised to the power minus 1. And after we might differentiate, our answer is s squared minus 2. And that is the graph of this function. Okay, that's our arrangement. Let's look at the next differentiation rule that we have here. Rewriting functions as sum of terms in power of s before we differentiate. So when we have a function that has either denominator or numerator, what we just need to do is that we try as much as possible to rewrite those functions as a sum of the term. So we are going to be solving this class activity here. Okay, we have to differentiate the function f of s equals to 2x raised to the power 3 plus x raised to the power 2 all divided by s with respect to x. So we have y equals to 2x raised to the power 3 plus x raised to the power 2 all over x. So let's split this denominator and have a fraction of an individual fraction. So we have y equals to 2x raised to the power 3 all divided by s plus x raised to the power 2 divided by x. You know, s can actually go in s raised to the power 3, so we can have this one to be 2x raised to the power 2, right? So plus s can go in s raised to the power 2, we have x left, so we have x. Now let's differentiate this. We have the y dx. We are differentiating it with respect to x, so we have 2 multiplied by 2 x 2 minus 1. A here is what? A is 2, so plus x 1 minus 1. The coefficient of x here is what? 1. So we have 2 multiplied by 2 will give us 4. X 2 minus 1, that is 1. So we have 4x. X raised to the power 1 minus 1. 1 minus 1 will give us 0. So x raised to the power 0 will give us 1. And that is the solution set for that problem. Now let's rearrange the activities that we have here by dropping the right answers to the right boxes. So the y dx is calculated as this, okay? Now if we have, after dividing x with the numerator, we are going to be having to x raised to the power 2 plus x, okay? Now after we are done differentiating based on the working we show, our answer is 4x plus 1. Okay, now let's check the remember we are cool. Now let's look at how to calculate second derivative. The first one we did in the previous slide was first derivative. What do we mean by derivative? First one, derivative. All we just did was we are differentiating only once. But right here, we are differentiating twice. So that implies that after we are done with the first differentiation, we pick the answer we've gotten for the first differentiation and differentiate again. And that makes it the second time. And the formula here is what? The y over the t into bracket, the y over the s over the t. That implies that you are differentiating 2 times. The solution you get from the first differentiation, you differentiate it again at the second time. Okay, now let's look at this activity that we have here and let's differentiate this equation. So we have to find the second derivative of the function y equals to x raised to power 3 minus 2x raised to power 2. Now let's differentiate the first time. We call this type of differentiation the first one as first derivative. So we have the y over the x equals to 3x, 3 minus 1 minus 2 multiplied by 2. We are bringing the n to multiply it. Okay, x to minus 1. So that is going to be what? Okay, we have a coefficient. Okay, we have it here. So we have 3x, 3 minus 1 will give us what? That is 2 minus 4. 2 times 2 is 4. So we have 4. 2 minus 1 is what? 1. So we have 4x. And that's the first derivative. So we are differentiating this again. And that's what the second how the second derivative comes in. So we have to differentiate this again, and that is the second derivative. So we can indicate it as this second derivative. So we have it to be what? How do we differentiate it? That's going to be 3 multiplied by 2x, 2 minus 1, because here the n is 2. Okay, 2 minus 1. Okay, we have 4x, x raised to power here, so we have 1 minus 1. So we have it to be 3 times 2 is what? 6. So we have 2 minus 1, that is 2. So we have 6x plus. Okay, we are dealing with minus, so we have this one to be minus and not plus. Okay, so we have x raised to power 1 minus 1, that is x raised to power 0. X raised to power 0 is 1. 4 times 1 will give us 4. And that's the solution to that activity. So let's draw the right answer to the boxes. So by the time we are done with differentiation, the very first time we differentiate, our answer is going to be 3x raised to power 2 minus 4x. So by the time we differentiate the second time, our answer is going to be 6x minus 4. Let's check. Okay, now let's look at the example again we have here. It's an work activity. So let's try to differentiate this. You know, instead of x here, we now have it with we are differentiating x with respect to t. So beforehand we have actually been differentiating y with respect to x. So let's differentiate x here with respect to t, and let's see what we have. So we have differentiate the second derivative of the function x equals to 3t minus 1 over t raised to power 2. So x here now, instead of that we have x equals to 3t minus 1 over 2 x raised to power 2, right? Okay, so the very first time we are having the x over the t, that implies that we have that's the first differentiation. The x over the t equals to, we have 3 multiplied by t 1 minus 1 minus 1 over 2. N here is 2, so we are bringing it to multiply half. We have 2 equals to okay, this is t, so we have t 2 minus 1. So having that, we have 3 here, because t raised to power 1 minus 1 is 0. N raised to power 0 will give us 1, right? So we have 3 here minus here, have 2, we can cancel 2 here, so we have t minus 2. So if we have t minus 2, that is 2 minus 1. What is 2 minus 1? 2 minus 1 will give us 1. So here we have t, that is the first derivative. So for us to get second derivative, that implies that we are differentiating with respect to t once again. So if you look at this, let's differentiate this. This one will give us 3 multiplied by 0, t 0 minus 1 multiplied by t 1 minus 1. This one, 3 times 0 will give us 0. So 0 multiplied by all of this will give us 0. Okay, now we have it to be what? Minus, okay, t 1 minus 1. T minus 1 minus 1. 1 minus 1 is 0. So anything raised to power 0 will give us what? 1. So we have it to be 1. So 0 minus 1 will give us minus 1. And that is the answer to the question. So let's look at the past question we have on the next slide. Okay, in this past question we have y equals to 2x raised to power p plus qx raised to power 2. They have already differentiated it first time, and by the time we differentiate the very first time, our answer is 14x raised to power 6 plus 6s. So what we just need to do here is that we have to find the value of p and find the value of q. So from here, let's bring out the formula for the differentiation, which is what? We are the y over the t, the x equals to x raised to power n minus 1. So from here, they have already differentiated this expression to be what? The first differentiation, which is the y dx equals to 14x 6 plus 6s. So that implies that if you are to differentiate the y with respect to x now, the first one here is going to be 2 multiplied by p, x p minus 1, isn't it? Okay, plus q multiplied by 2 s to minus 1. So having that is going to be what? 2p x p minus 1, okay, plus 2q s. 2 minus 1 is what? 1. So we have x. Now what we need to look at is our solution is what? 14x raised to power 6 plus 6s. So what is missing here is, what is that value that by the time you multiply with 2 will give us 14? And what is that value that by the time you multiply with 2 will give us 6 here? So by the time we think, if you multiply 7 with p, 2 here, is going to give us 14. So let's see, we have 2 multiplied by 7, okay, x 7 minus 1 plus, if you look at this, to get 6, that is 2 multiplied by 3. So you are going to be having 2 multiplied by 3x. So let's look at the expression if you are going to get this answer. So 2 times 7 is going to give us 14, right? Now 7 minus 1, 7 minus 1 is what? 6, okay? Plus 2 times 3 is what? 6, okay? X. So that implies that for this expression, our p is going to be 7 and our q is going to be what? 3. And this gives us the solution to the question we have here. This takes us to the end of our class. We want you to subscribe to our channel www.edubay.com for the full interactive content of this class.